Hello everyone, I'm Prakriti P, a first year computer science engineering student studying in SVCE, and today I'm here to speak about the topic numerical methods in the subject mathematics for CSC stream. And today I'll be covering the contents numerical methods and finite differences operators, a difference between forward and backward differences, interpolation and its types, regular falsy method, and Newton-Raphson method. So, what is numerical method? Numerical method is basically a mathematical tool which is used to solve numerical problems. And the implementation of this numerical method with appropriate convergence check in a programming language is called as numerical algorithm. So the next topic is finite differences. Finite difference method or finite differences. It's an approximate method, which is this method is also used for solving partial differential equations, and it's used to solve a wide range of problems, which includes the linear, nonlinear, time independent, and independent problems. And the mathematical function of this finite difference is f of x plus b minus f of plus a, the whole divided by b minus a. And the next topic is difference operations. There are mainly three difference operators, which is namely forward difference operators, backward difference operators, and central difference operators. Today I'll be speaking about forward and backward difference operators. So first is the forward difference operators, and in forward difference operators, the symbol delta is used, and it's a triangle shape. And for example of this forward difference operator is that we'll take let y equals to f of x, which is a given function of x, and let y naught, y1, y2 till the unknown be the values of y, and at um, x equals to, which is x naught, x1, x2, and till the unknown respectively. And the formula for this forward difference operator is x minus x naught minus nh, uh, f the power n plus 1, which is multiplied by x, and it is as a whole it's divided by n plus 1. So, what is the next topic is backward difference operators. In backward difference operators, in upside down triangle, which is known as NIPLA, is the symbol of backward difference operator. And basically, the Newton's backward difference, it is also known as the Newton's backward difference formula, and which is used for approximating a function with n degree polynomial passing through n plus 1, which is equally spaced the points, and where s is equals to x minus x1 divided by x1 minus x naught, where nf1 is the backward difference of the f at x1. So, what is the difference between the forward and backward differences? It's that in numerical methods we can see, we are very familiar with the finite difference table, where we can identify both the backward and forward differences, but in the same table. But the only we can the only thing which makes the both of them different and we can identify them is through its notations, which is the forward for the forward difference. It's delta y equals to yn plus 1 minus yn delta, whereas for the backward difference, it's nepla y equals to yn minus yn minus 1. So the next topic is interpolation. It's an interpolation is basically a mathematical procedure which is used to derive a value between 2 points, which is having a prescribed value. We can also explain in simple terms that it's a process of approximating the value of a given function uh, given at a set of discrete points, and hence we can one can apply it in estimated varied cost and concepts and mathematics and statistics, etc. So the formula for interpolation is y equals to y1 plus y2 minus y1, the whole divided by x2 minus x1, which is multiplied by x minus x1. So there are the types of interpolation method. There are mainly two types of interpolation method, which is the forward interpolation formula and the backward interpolation formula. And the forward interpolation formula is mainly useful for the interpolating the values of fx near the beginning of the set of values, where h is the interval of difference and u is equals to x minus a divided by h. And for example is that the value of sine 52. It's an example of forward interpolation formula. And for the backward interpolation formula, it's also a very useful formula when it comes to the value of f of x when it's required near the end of the table, uh, which means that h is the here also the h is the interval of difference, and its formula is that u is equals to x minus a n, the whole divided by h, where it is the last term. And the example of backward interpolation formula is uh, population in 1925. The next topic is regular falsy method. The regular falsy method is also known as false method, method of false position or false position method. It's a very old and which is old method which is used for solving the equation with one unknown, and this regular falsy method was modified, and then it is still in use. And we can say that it can also be referred as a trial and error technique, which means that the values for the variable is first adjusted variable. We use the values for the variable, and then we adjust the test value according to its outcome. And it can also be sometimes referred as guess and check versions, which means it's a method to predict the advent of algebra and use of equations. And the example for regular falsy method is given here, which where the it's an equation where x plus x divided by 4 equals to 15. And first then this is solved by the regular falsy method, where the first case is that x is equals to 4, and which means 4 plus 4 divided by 4 equals to 5. Then the choice produces an integer value, and then if 4 is not the solution of the original equation, it gives a value which is 3 times smaller, or to compensate multiply x by 3, and then substitute it again, which means we get 12 plus 12 divided by 4, which is equal to 15. If we verify that, the solution is actually x is equals to 12. So now we get into the derivation of a regular falsy method for its mathematical expression. So the as we can see the picture, first we have to connect the points A f of A and B f of B with a straight line. Then the regular falsy method, we get the regular falsy point, which is x dp, which is then the solution of the linear equation by connecting the endpoints. And as we look at the sign of f of x dp, then if f of x dp is less than e, which means it's an end algorithm. If f of x dp is equal to sine f of a, then a is equals to x dp. Otherwise, it's b is equals to x dp. So by solving the equation of this line, we get the final mathematical expression, which is x dp is equals to a minus f of a, which is multiplied by b minus a, which is wholly divided by f of b, which is again subtracted by f of a. And the last topic is Newton-Raphson method. So this method is also a numerical method which is used to approximate the roots of any given real valued function. In this, we use various iterations to approximate the roots. If and the higher the number of iterations, there are less errors in the value of the calculated root. And the mathematical expression or the formula for Newton-Raphson method is which is x n plus 1, which is equals to xn minus f of xn divided by f of f dash of x uh, n. And now I would like to conclude this presentation by saying that numerical methods are it helps us in many ways by providing the solution for the problems very quickly and easily when compared to analytical solutions. Even if we are solving an integration or differential equation problems, which is a complex, which are very complex, but if we use the numerical methods, we can reduce the solutions, and it can be easier to solve, and it makes us easier to understand the problem than compared to the analytical math. uh, Sometimes it can be very difficult to solve the problems through analytical math. Even a simple problem can be complicated, so we can use this numerical methods and solve the problems. And this was the end of my presentation, and I'm really thankful for you guys